Hello everyone and welcome back. I am Mr. Cobalt and today we are going to go over another problem of limiting reactants. In this problem, again, your typical limiting reactant problem is where they give you a balanced equation or they ask you to balance the equation, right? So there's different levels of difficulty, but at some point either they give you the balanced equation or they ask you to balance an equation. But either way, you need a balanced equation, and they give you two amounts of each reactant. So one amount of each reactant, and they don't really tell you much more than that. And they say find the limiting reagent or find the theoretical yield, and so on. And so you have to figure out whether or not you have the right proportion of reactants to react completely with each other. Otherwise, you're going to be left over with an excess of one, and you're going to have zero of the other. And the limiting reagent is what you're going to run out of first. So that is why it's called the limiting reactant. It limits how much product you can produce. Okay, so in this problem, they give you this reactant. This is the reactant of how to, make solid titanium. And so there you have this. You have titanium 4 oxide reacting with carbon, solid carbon. It produces titanium solid and carbon monoxide, and this is the balanced equation. They give you 88.2 kilograms of the titanium 4 oxide, and they give you 28.6 kilograms of carbon. And they also tell you that this reaction in the lab produced 42.8 kilograms of the titanium solid. And so they want you to find the theoretical yield and the limiting reactant, and they want you to find the percent yield. So that's why they're giving you the actual amount. So this is your actual amount that's produced in the lab. Your theoretical yield is the theoretical amount, meaning what you should get in theory or according to your calculations. So you need to calculate the theoretical yield and then use that to find the percent yield. So I'm going to go over each of these. So again, since they are giving you mass amounts and they want you to find the theoretical yield, and you're going to need to get the mass amount to calculate your percent yield, you might as well just convert everything all the way to mass of titanium. And so that way, in the end, you'll figure out what your theoretical yield is, you'll figure out what your limiting reagent is, and then it'll just be one step to get to your percent yield. Or you could just convert both of these to moles and take the mole amount and then go from there, right? So that's another way to do it. So let's do it that way because that will lessen the amount of calculations we have to do. So we're going to start with the 88.2. So 88.2 kilograms of the titanium 4 oxide. And we're going to put that over 1. First thing we need to do, if we're going to convert this to moles, so we could use our mole ratio to get to titanium, then we need to convert this to grams. So we need to use that relationship of kilograms to grams. Again, you put the 1 with the prefix, the unit with the prefix, and then the prefix multiplier for kilo goes with the base unit. So kilo is 10 to the 3. So I put 10 to the 3. So I'm going to, since I have kilograms on top, I'm going to put kilograms on the bottom. So 1 kilogram of titanium 4 oxide, TiO2. And then I'm going to put 10 to the 3rd grams of TiO2. Sorry about that. I had to make sure the window was closed. It's kind of noisy. So here I have the conversion factor. So here I have kilograms of titanium oxide. That's going to be canceled out. Now I have grams of titanium oxide. So now I can use the molar mass of titanium oxide. So the molar mass is 79.87 grams per mole. And so I'm going to now use that as a conversion factor. And so here, since I have grams on top, I'm going to have grams on the bottom. So 79.89 grams of the TiO2, and then 1 mole of the TiO2 on the top. So grams of TiO2 cancel out. And now I have moles of TiO2. Now I can use my mole ratio. So 1 mole of TiO2 to 1 mole of titanium. So now I can use that. So 1 mole of the TiO2 on the bottom and 1 mole of the Ti or titanium on the top. So moles of the titanium oxide cancel out. Now I have moles of Ti, and so now I can calculate the number of moles of Ti. And so if I do that really quick, so I have 88.2 times 10 to the third, which is 1,000, times 1 divided by 79 divided by 79.89 equals, and here I get 1104. So I get 1104.018 moles of titanium. So that's the number of moles of titanium I get from 88.2 kilograms of the titanium oxide. Now I do the same thing with carbon. So I start with 28.6 kilograms of carbon. First step again is convert kilograms to grams. So I'm going to use the same conversion factor. So 1 kilogram of carbon on the bottom, 10 to the third grams of carbon on top. Kilograms of carbon cancel out. Next, I'm going to use the molar mass of carbon, which is here, so 12.01. So 12.01, so 12.01 grams of carbon on the bottom, 1 mole of carbon on top, so grams of carbon cancels out. And now that I have moles of carbon, I can use the mole ratio of carbon and titanium. So here it's 2 to 1. So here I have 2 moles of carbon on the bottom and 1 mole of titanium on top. Moles of carbon cancel out. Now I'm left with moles of titanium. So now I can calculate that. So I have 28.6 times 10 to the third, which is 1,000, and then these are ones. So now I'm going to divide by the bottom, which is 12.01 divided by 2 equals, and I get 1190. So 1190.674 moles of titanium. So now I can see which one is going to give me the theoretical yield. So I have 1104 and I have 1190. 1104 is the lesser amount. So that's going to give me my theoretical yield, and that tells me that the titanium 4 oxide is the limiting reagent. So that limiting reagent is TiO2, and that means that the other one will be in excess. So carbon will be in excess, and then my titanium 4 oxide is going to be the limiting. It's going to be 0, so it's going to run out first. Okay, so now since I know that this is the lesser amount, I can continue with that one. So I have 1104.018 grams, or moles, sorry, moles of the titanium. And now I'm going to convert that to kilograms. And I wanted to convert to kilograms because they give me titanium in my actual amount in kilograms, and so I need to get kilograms so that way I can do my percent yield. So first thing I need to do is use the molar mass of titanium, 4787 grams. So so 1 mole on the bottom, 1 mole of the titanium on the bottom, and the 4787 grams of titanium on the top. So moles cancel out, and now I have grams of titanium. Now I can use this relationship to convert to kilograms. So I'm going to put grams on the bottom. So now I have 10 to the 3rd grams of titanium on the bottom, and I have 1 kilogram of titanium on the top. So grams of titanium cancel out, and now I have kilograms. So now I can calculate the number of kilograms. So I have 1104.018 times 47.87, and then divided by 10 to the 3rd equals, and that gives me 52,849. So that gives me 52.849 kilograms of the titanium. And so now what I have, this is my theoretical yield. I have to decide on the number of sig figs. So anything that's exact, so the kilograms to grams is exact, I'm going to ignore that. This again, kilograms to grams, I'm going to ignore. I'm going to ignore the 1 to 2 ratio because that's exact. So, and all the molar masses I will pay attention to. So I have 47 here. So I have, that's going to be 4 sig figs. I have 12, that's going to be 4 sig figs. This calculation came from here. Oops, I'm looking at the wrong one. So I have this and this. So that's going to be 4 each. That's going to be exact. That's going to be exact. And I have 3 sig figs here. So the lesser amount is 3. So that means 1, 2, 3. I cut it off here. So 52.8 kilograms of titanium would be what I would report. So that would be the theoretical yield. 52.8 kilograms of titanium. And then finally, the percent yield. So what I'm going to do now is I'm going to take the actual amount. So you take the actual amount, 42.8 kilograms, divide that by 52.8 kilograms of Ti, and you multiply that by 100, and that should give you the percent yield. So if I do that really quickly, so you get 42.8 divided by 52.8 times 100 equals, and then you get 81.06. So 81.06% yield. You gotta, since you have 3 sig figs, you gotta turn that to a 1. So that would be the percent yield. Thanks for joining me. Share the video, subscribe to the channel. I'll see you.